Hello and welcome back. Today I have another signal generator and it goes up to 80 megahertz. So that is really something. And I already had the field tech here, but it goes up to 60. And I have the Unity that also goes to 60 megahertz. Both are connected to external reference. The field tech had 10 megahertz and the Unity at 50 megahertz, which was a little bit less practical, but I have my 6th channel PLL, so that was solved. And I heard good things about this. And this type number is the PSG9080. And it looks a lot like the Juntek. And I heard good things about the Juntek. And also, Juntek just provides online the firmware updates. And I've been looking around and I didn't see that for the field tech and not for the Unity. They do have software, but I didn't find the firmware. And Juntek seemed to do that a lot better. I took a little bit of a risk here because it doesn't say Juntek on the box. Also, not the sticker here didn't say Juntek. And I bought this one, so I will call it a white label Juntek. And the picture also didn't say Juntek. This one was around 140, including the shipping. And if you want a real official Juntek, you are looking at 175 up to some even sell it above 200. And so I thought let's take the risk. And the seller didn't put anywhere the name Juntek, and it only said it was the PSG 9080, and it looks the same, and the type number is the same. So let's see what we have gotten. So if we look at the box, it indeed doesn't say Juntek because usually that is here. But the rest I saw a box on another review, and it looks more or less the same. Only then this sticker said Juntek, and here it just says signal generator. But then if we look a little bit further, here we see it is from Juntek. So that is already a little bit of that feels good because I really felt like I was taking a risk because then you save like $40 or $50, and then in the end you end up with something completely different. So, but we are not sure yet. Huh? Very nicely packed. I already like it. It's a lot bigger because the field tech the field tech was really a lot smaller than these devices, and then it just well, for me it was convenient because otherwise it could not have fit here, but it fits here because I just move around just until it fits. But if I want, for instance, put it here, then I like that it is the standard size, and this one comes close to the standard size. So we go back. It passed quality, that is nice. Well, even the manual says Juntek here, but it also says here pictures were taken from the PSG as an example. And so even it says Juntek here, they say themselves it is an example, so it still could be a white label. But it makes me feel already better little by little. You can even find the manual. I already downloaded it. I even found the firmware, so I will put everything on the links below, just in one big zip file, so you don't have to go after it. Let me take this out. Well, it is not that heavy. It is all plastic, but it does look good. It doesn't feel that super fake plastic. Oh, look at that. So I will leave also the link to this product because it is actually a real Juntek. Okay, modulation in, external in. This could be the frequency counter. Channel 1, channel 2. Button. Can turn, not push. That looks great. And I like you can directly input. This is sort of rubber. Well, it has the feet. If it sticks out too much, you can just take it out. And what we have in the back, sync in and out. We have some TTL serial stuff, USB. 5 volts in, and 85 to 264. So you can almost put everything in. That is good. Okay, it's nice with the book, proper cable, USB, BNC, yeah, I will use proper ones, and BNC crocodiles I probably also use proper ones, but this is useful. Let's power it on. Okay, and I also found even in the button, it just says Juntek, so this is a real Juntek. So you can indeed sometimes take the risk. Let me switch it on. The power is on and it doesn't switch on perfect. So I don't need to put the switch on the, yeah, perfect. Juntek. This is really the first started. Let me first remove this little thing. Carefully take that out. I like it, the big display. Let's speak English. Wow, that does not look bad at all. Only the beeps sound a bit loud, I think. Yeah, it's a bit loud for me. But look, cool. Let's go to system, sound, turn off the sound. What else we can do? Brightness, well, it's good. Language English, built-in waveforms. I think that's information, because that would be great if you just can increase that. Yes, you can. You can make them less. I'll put them on in the most. Arbitraries. We put them to the maximum available. 99. Perfect. Are there more pages? System information. About. Download the software hardware version 1.2 firmware version. Yeah, I have seen indeed that there are versions 1.2 and 1.3. So this is still on. This is still 1.2 then. Okay. You can update. I haven't seen newer firmwares available than that. Maybe I should save this. Well, the controls look nice. You can just type if you want wave, and then you can here select squares or, but if you push again, you also have a visualization, and then it is much nicer to see what you are picking. Or you do frequency, and you can start dialing. You can move your cursor to what you want to change. Or you can start typing, because if I say 10 and then I pick megahertz off, it's there also. So I like you can have your direct input. You can change your amplitudes, say with the cursor, or to move, or you start typing, I think. So if I say now 5 volt, big, tube, I have 5 volts, big. Very easy, and probably by clicking the channel, I move to this channel. I have here, there is a little hand here, or no, the hand is here. So really good. How accurate is it? Well, have a look. Okay, I've set here 10 megahertz, and as you can see on the frequency counter, it is not. And now we can see if we can change that really easy, and I think we could. Page down, here we have the frequency offset, fine tuning. I don't know how I just put it to 60 first to see where it goes. Save. Oh yes, it did change. I'm just a bit impatient, so we go back to 70. I'm not sure I need to save it or it responds immediately. It responds immediately. Okay. Yeah, now it's too low. 68 is too low. And if I go to 69, it is too high. And this is, I usually like higher because it looks better in the display. And, but yeah, this is 2.2 and this is 3 point, this is 3. So then this is closer. Okay, save. And if we go back home, what does it do on 80 megahertz? Maybe I need to adjust again on 80, maybe better. I can turn the knob or type puff 80, go back to system. And my frequency counter is of course connected to a GPSDO for my lab reference. Let's see if we can get it closer. Now it's 14 too high. Yeah, this is 30. So this is really the best setting. And it's getting closer. It's slowly seeding also. I think this one is okay. 69. So the default 50 was not even that good. And maybe also, now it's getting closer and closer. And also, of course, maybe the oscillator, because it's now brand new, needs also to wear in. It's like we can do a little bit slower just to see. I will do time lapse. This is interesting, and I can do a very long gate time. Well, it is getting closer and closer, and also I can add an extra digit here, but then it's always getting a little bit nervous. And if I extend the time, we can even go more precise, but that will take a while. Well, it is slowly getting there, but it really takes a while. And this is also a little bit harder to read because you need to cut, but these are the hertzes, I think. So if I take this out and I do a little bit less, then it's easier to read. Yes, and you can see it's like 20 hertz off, so that is not that bad, but it is still slowly heating and getting better and better. I switched it back to 1 megahertz so we can see all the waveforms. Square. This is pulse, but the pulse is 50%. Oh, with the 0 offset, so that's going to be the same. Triangles, ramps. Well, that also looks like a square. We have the sine. We have half sines. Okay. Double, like a rectifier. A ladder. Reverse ladder. Traps. Negative traps. Noise. Arise. Oh, cool. I'm playing a little bit more with the frequency, and I'm on 1 megahertz. And the 1 megahertz, it seems it is pretty good. But also now the frequency goes slowly up again. So it is also when you run on high frequencies, it is getting hotter, and that influences the frequency because now it's going up slowly. We will find the tree later. Because now it's cooling down. And you see that the average is a little bit higher. 28, 29, 30, now it goes up. But if I go to 80 megahertz, then it starts to heat up. And then the frequency goes down again. So if I go now to 80 again, 80 megahertz, then you will see the frequency going to drop again because it gets hot. So you really want external reference, I think. Yeah, now it starts to drop again. Now it's getting hot. Well, these tests I never did with the field tech and the Unity. The temperature will always be an issue. And so we just leave it at that, and that's why I usually use external reference for everything. I built external reference on the field tech, I built external reference on the Unity, so I will have a look what is the reference oscillator here. I like to see the frequency counter. I think shift counter, yes. First, let's put, we can put here the 10 megahertz, my 10 megahertz reference right there. Yes, of course, it agrees. The modulation input. Start measuring. And yes, because it is off, this will also be off. Yes, well, it is clear that the adjustments that we did are only for the outputs because the counter is really not changing it. This is 101 hertz off, and well, if you can see, it really should not be. Yeah, and the result here is just always one digit. No, that's always the problem with counters. Okay, well, we leave it as it is. It is a little bit off. Now I'd like to see how high it goes. How high can it count? So let me put here. This is 210 megahertz. It is just what is there. It is locked, this channel 1. Oh, this one doesn't get that. It needs to go on my other ports. Here it is. Yes, 200. And no, it doesn't take that. Why not? It is pretty loud, the signal, but it is just not doing that. And let me see, there is a filter here. Okay, you can change the filter. We are AC coupling. This is the gate time. Well, no use to change it until we want to be more precise. There is a high filter above 2K. That's good because now it's low filter. It's below 2K. So the setting is good. Yes, we can do longer, but it's clearly it doesn't lock. So maybe I need to go a little bit lower. Let's go to, and I'm putting quite some because I'm putting 3 volt. So that is really a lot. Back to 208. No. 200. Yeah, it does seem to count 200. So above 200, it is really gone. And it needs a lot of signal because I'm really putting a 3 volt peak. Okay, I put it now on 10 seconds gate time. That's also the maximum. And as you can see on 200 megahertz, here we are spot on. We are 2 kilohertz off. Okay, we did do some quick tests. Yeah, I think we do agree. We need external reference. I like that. We're gonna open it and see if that is possible. And yeah, let's just start. We all want to see the inside. Come. So. Yeah. Turn it. Is it a standard size? It is way too big. That is a pity. But it can fit on top of this one, maybe. Okay. Yeah, it is like the 01, but it's even a little bit higher than the 01. But this is rubber, so we can cut that off maybe. But it will probably just fit on top of here. So let's see. Well, first we just open. Because if I'm gonna place it, it will be probably here on top of the power supply. Because I think the rest, I don't have too much space. It looks like they made it a little bit too big. How does this work? I have those special tools. No, don't need. Here it goes. Okay. Now the power supply looks a lot better. Okay, 4 screws. Zoom in. Okay, that does look a lot better. I don't know if you remember from the field tech from one of my other teardowns, they use these flat cables, but even thinner. They use for the AC to connect to the power supply, and also the voltage they put from here to here was also with these flat cables, but even thinner than these ones. So this is really nice. And what they also did, because the whole casing is plastic, that they isolated completely the ground. Probably because otherwise it could just be connected to here, and I didn't. I don't know if that is what you want, but at least it is possible. So we need to measure if that is the case, and maybe we can even make it switchable. If you want to link it, you just put a switch between this one and this one here in the back. Let me quickly get a meter. Okay, let's do some measuring. This to this one. Okay, so this goes to the ground and probably also to this ground. Yes, it does. Is it isolated from this one? Yes. Okay, so that means it is completely floating from here to here, which could be nice, but it could also see maybe that you don't want that. So I can indeed make a switch to switch this one, and then it just goes to real ground. Okay, because when I'm going to play with external reference, all the grounds will be connected anyway because of the coax, and then I don't want to have any current through my coax. So then I really want to connect those two. Okay, but it's easily done. Here there are little screws. Let me show you. So the ground here is just connected with the little screw. So we can just add the extra wire there, go to here, put the switch here in the back, and connect it to this ground. And then we're not gonna play with this little thing in the back, because why should we? We can just put the switch, and then if we decide later if we want it floating, you just flip the switch. So that's a good thing. But I really like what I did with the power supply. It really does look a lot better. Is that at least they used properly rated wires, some proper isolation here on the pins. Yeah, yeah, they did a lot better. Okay, we're looking at the main board. Well, we have some relays to switch the output. Here are the drivers to get the signal out. They have some cooling. Well, we saw that the temperature changes, so maybe if you run it on a long time on the high frequencies, maybe you want to build in a little ventilator. I cannot really see, so I need to get the microscope, but it looks like most of the circuits have been shaved off. This one is still here. Let me see, do we see oscillators? I think there is one. I need to get the microscope. And it looks like you can add 2 BNCs there in the back. There are also holes in the back. Maybe we can trace down what it is, but the field tech also had 4, and I don't really remember what it was, but it was not an external reference. I hope this works, because it is nice that the microscope has a stand and all, but I hope I can see. Maybe we can have a look at the yip. Oh, yes. Okay, no. It is a Spartan. XC. I need to look a bit better. Okay, zoom in a little bit. As you can see, it is a Spartan, but it is an XC6SLX9. Okay, I added now some of the extra lights, and now it's a lot easier to see. Okay, we can find out more about it later. Here it is all shaved off. Yeah, the rest is not much to see. That's the 340. That is the USB. But I am looking for the here 50. I want 10. Yeah, clear. 50 megahertz. It runs on 50. And like any other generator, so it goes with it. The signal is probably on the 33 ohms resistor that goes directly into the chip. Yeah. So and the caps that you see are just for the voltage. Okay, let's have a look. I really like the fact that when you power it on, it doesn't switch on. Because in the field tech I needed to create an extra switch because I really don't like that. Because my whole desk just goes off when I leave. And yeah, you really need to switch it on first, and you can even change that setting, so that is also nice. This I don't understand why it starts up in the program mode. Okay, I did something weird there. It just started up every time in the programming mode, and it just reset it to factory defaults. Switch off the beep and put the frequency correction at 70 again. And so that is back to normal now. And now I like to see the external reference. The reference, what is it run on? Well, we saw that the ground was the ground, so we can just pick it here. And I want it to be on the resistor. It is this one. Yes, this is the 50 megahertz. And I'm measuring from the ground, this ground. And how hard it is? Okay, very low. It's 1.36 peak. 1.2 behind the resistor, and the chip still works great. And I think that is exactly what also comes out of my PLL. What I did with the Unity port 4 was also, yeah, look, shape looks the same. It's a little bit louder. Okay, I can use that. That looks the same. Yeah, well, there is probably nothing wrong with the device. It's just that the oscillator, maybe we were a bit unlucky because it's 50 hertz off. And then you can try to correct all kind of ways, but if it's not good, it is not good. So I think for another time. external reference. Okay, now I like to play with the software. What I usually do is I open the device manager. We already saw in the microscope that it is just the standard USB, so we'll probably find it here. And I will be plugging in the cable, so there is no need to install a driver, I think, because it will be 340. Yes, and here it comes. It is COM5. Okay, now let's install the software. Okay, I downloaded the zip file, so it's probably in my downloads. Sorted to date. Okay, PSG9080 extract. Just do that in this folder. Okay, and we have now PSG. Yeah, right here. Okay, then we go to English. The C340, that's the driver. That is what you need for the USB port, but we already saw that it was immediately detected. So then we just go here. We have software description, communication protocol, application, and we go to the setup. We agree. Yes, let's put it down. All users, I don't mind. I'm the only one. Okay, and then we just wait for the flashing to be over. That was fast. And we need to reboot, so let's do that. Okay, so we have rebooted. I'm now starting the DTS generator. Okay, and we need to look what this is. This is usually we need to register some DLLs or OCX files. Okay, yeah, that is a bit silly. Something in the installation program doesn't register all the OCXs and DLLs correctly, so I just try to register them all. I think the MESA failed and the rest were typos, so I will take that away later, and then I will give you a list how you can do this. And after you register the DLLs, it seems to be working. We need to see if we can select the COM port, and that is COM5, so that is correct. And then we can probably click connect, and yes, it detects, so that probably is the solution. And look at this, this is cool. Can we switch it on and off? Yes, it does. You can hear it click. So we have connection. Cool, that's how you install it. Bit complicated, but it is possible. So okay, the remote control works. Well, you can do exactly the same as in the front. And for these options it's maybe not necessary, but if you look here in the modulation function, that does make a lot of sense, because with your mouse and your keyboard it is a lot more easy to do these things. And even here we have also a lot of options. This is the frequency counter, and well, all your extra functions are here. This looks nice. What else we have here? We can design our waves. Here we have a setup with this basic setup. Okay, that is the screen that we saw. We have sync setup, and there is a help version update. What does that do? Okay. No, perfect. So, well, the software install was a little bit messy and a hassle. Apparently, they don't register the DLLs and the OCX is correct. Is what it is. Frequency was also a little bit off, but we're going to fix that next time with an external reference. And it does indeed fit perfectly in the stack. So I like that. Well, I hope you stay around next time for the modifications of the that we put the ground with the switch. So we can select the ground on and off, coupled or floating, and the external reference. Thank you for watching, and I hope to see you next time.